I'm going to try to implement the trace protocol in less than 10 minutes. Okay, so all you have to do is it's input, process, output. I've never done this, by the way, in make.com. So my input is going to be Google Sheet. I'm just going to watch for new rows. I'll make a new sheet for this. Sheets.new. I'll call it trace protocol. Process, I'm just going to call ChatGPT. I'll add two numbers, or what should I do? I'll generate a mood estimate or something like that. So that means that this is going to be called brain dumps. I think I want to give it a date time and the content. Okay, I'm at 2 minutes. All right, then the output is just a different sheet, which is going to be mood estimate. That's also going to have a date time and the content. And this is going to be Google Sheets, add a row. Or should it be update a row? In N8N they have add or update a row, so I don't know. Let me see what else is there. Or I'll just do add a row. This is going to be the most basic form of the trace protocol. Or so this is like trace architecture, I guess I would say. But it's not. Is it temporal yet? Yeah, I don't know. It could be. There's other stuff you could add. Okay, so this is going to watch. I'm going to search for it. I'm going to watch brain dumps. Yes, there's headers. And yeah, okay. Never done that before. Okay, so let's run this and see if it works. Okay, so can I watch this? Okay, you have to set this up. Alright, let me set this up. This should be good. But I actually want this. Okay, got the row. Should be able to add that now. Add the content. And I can even add the date time. Um, 6 minutes, okay. And this is going to be mood estimate. We'll put in the daytime, which should be the same daytime as before, because you can, that's how you can track data points over time, is if you save the same data, the same date time as what the original data point is and use that as the key. So there's a lot of different ways you could do this, but this is one way. That's how you can make it like pretty much instantly temporal. And then you can derive everything from that you need. And then if there's, so obviously there's questions about like backfilling and all that stuff, but this is the minimal version. Where's the date time? This one from that earlier cell. Content is going to be the response from the prompt. Where's that at? Here, I'm going to enter actual real brain dump. Cool. All right, so I'm going to put now. Why can't I? Okay, yeah, here's the result. Let's just run it. Okay, cool. So we got our first mood estimate, which is exactly what I wanted. This is showing how the architecture that I described is like super simple at its core. And all it is input, process, output. And so you can have this, you can make another one of these. So in make.com, you would make a new, I think that'll work. Okay, we can copy it, clone it from a different, so say that was your, all the stuff that would listen to the brain dump, you would attach it onto that. And then all the stuff that would listen to the brain dump mood estimate would listen to this one. So I'll make that one now. So that one should be called, okay, that's 10 minutes. But yeah, so I'm going to do, this one should be called brain dump, and this one will be called mood estimate. So all you got to do is watch for the mood estimate and then update your process. So I'll change it to like give me some, or no, what could I do based on a mood estimate? It's like recommend some songs, or recommend a song to put me in a better mood that's empathetic with this mood. And this is where you can get your Spotify data and create Spotify playlists, all that kind of stuff. So I'm just going to get, it says recommend a song to put me in a better mood that is empathetic with this mood. So it's got the date time and the brain dump estimate. Okay, so now I'm going to write to a recommended song. I'm going to make a new node called, or a new entity called recommended song based on mood. Okay, it's also going to have date, time, and content. And then update this. And we're just going to keep it the exact same. I'm not going to do the Spotify thing. I'm just going to get a text recommendation. If you look in the nodes, you'll find a Spotify node where you can do all these things. Create a playlist, update a playlist, get all your playlists, add an item to a playlist, search tracks, save a track, all this stuff. So you can define the process in the LLM node and then add whatever you want to happen there. And that's basically an action for an agent. So that is a functional representation. And if you don't know what that is, go watch the other videos. Yeah, recommend a song. Okay, so let me try this. All right, let's see what it said. Yeah, okay, so it recommended the song Walking on Sunshine, which is some basic song. But you can see now how you can chain stuff together from multiple implementations of this protocol. So if someone didn't want to use make.com, they wanted to use Google Cloud Functions, they could still write to the same database. Oh, by the way, okay, so there's a lot of other stuff I could go into, like certifications is an important one. This is just pub sub, really. But I think that's important for a basic understanding of the core of the protocol, because this tells you how easy it is to actually just do once. The other thing that I want to mention real quick is certifications, which is like you and someone else agree on some spreadsheet, and then when your data is ready in whatever spot, you can add a row to that certification spreadsheet, and that lets the other person know that the data is ready in that spot. So that way you can do stuff in a shared environment. Potentially you can run, for example, a privacy-preserving compute node and its data in some shared or whatever resource where the only thing that you're communicating is that, hey, the data is ready in that spot. And that's what's centralized or public or whatever layer of publicity that you want or privacy that you want. And the computation of the process on that input data, that can run wherever. What that does is like, it lets people have a common way to communicate no matter what their storage or compute is. And one example, a really simple example is like, if I wanted to give you access to all my Spotify songs, but only for a certain purpose, we could define that purpose together in a smart contract on a privacy-preserving execution chain. Like, there's a lot of different ways to do this depending on what you want to do. But we can define that prompt together in natural language, and that is the function. And these things can be built out by other people, but these things can be defined by anyone. So that way, all their data can connect without them having to go through a bunch of these different kinds of people, or parties is what I'm saying. I don't know if that made sense. That is one of the key points, is that kind of interoperability between different data sources with a common way to do that, and one that people can understand and define. you can think of it like you're defining all this stuff in like a workflow that's just one node to another node. And eventually there should be a UI that actually you can see all these nodes. You're defining all that stuff in some type of workflow. The way you're defining it is in natural language and pretty easy to get because it's just connecting concepts and defining what happens between the nodes. Like recommend some songs based on Jake's Spotify data and my mood estimate. And then you define that together and you deploy it to some thing that you understand, which this one is easy for people to understand so they could do that. And then you say, you specify somewhere, or basically there's different platforms that provide different compute functionality at this point. That's where you can specify that you want to run the execution and where the storage should be. So what I have now is like a bunch of different implementations and components that would be helpful for a protocol like this. Like a bunch of different UI versions, which are mostly XY flow UIs, if you know what that is, but you can look it up. It's like nodes and edges. And a lot of different versions of the back end. I will say that it was helpful to figure out what's possible to build using all these different implementations. But yeah, I've been talking to people about it, and so I think the best description in terms of feedback that I've gotten on it is that it's like a global computer, because what you are doing is defining abstract functionality at a really fine grain, and storage and compute is the fundamentals. I think it's a global computer. I think it's just like and I also think, by the way, I think this is how everything can be modeled, including in neuroscience, up to the level of quantum compute and quantum impact or quantum representation. Because I think you can kind of see how if you can pick your storage and compute and you want to represent this quantum reality, then you can pick a quantum computer as the compute layer for that specific functional representation. So yeah, now you can see, hopefully. All right, this is 20 minutes, but hopefully it made sense. All right.